Hello viewers, I am Ahmad, lead technical writer here at Xgrid. I spend my days helping teams turn complex technology into clear and practical documentation, and mostly my evenings geeking out about AI and its real world impact. Today, in this podcast, we are taking a deep dive into how generative AI is reshaping the way businesses work and make decisions. I have Abu Bakkar with me here today. He has a very profound understanding of generative AI and its production level applications. Abu Bakar, what do viewers want to know about yourself?
Hey, thanks for having me. I'm really excited to be here. I currently work at the intersection of applied AI and engineering. A big part of my focus has lately been helping businesses grow from AI curiosity to real production ready systems. GenAI has been opening up a ton of possibilities, but as many teams are finding out, the leap from prototype to production is where things get real. So I'm looking forward to diving into what works and what doesn't, and I've learned from the trenches.
Why do you think generative AI is gaining so much traction, specifically within businesses at this point in time?
Well, it's really a confluence of factors. Firstly, the underlying model capabilities, particularly with LLMs, language models, basically. So they have taken a quantum leap, in my opinion, and they're no longer just these interesting research projects that we heard about a long time ago, and they can actually perform genuinely useful tasks with a surprising degree of coherence and creativity. Secondly, accessibility has dramatically improved. So we can have some APIs from major players, and then we have some pre-trained models that lower the barrier to entry significantly. Businesses also don't necessarily need a massive R&D department to start experimenting with these models. So, thirdly, in my opinion, it's perhaps most crucially, there's a clear line to demonstrate the return on investments. So whether it's accelerating content generation, improving customer experience, response times, or like even aiding in code for us as engineers, it's really helping in generation and debugging of productivity gains, and cost savings is becoming really tangible. This, of course, is creating very competitive pressure, pushing for more businesses to explore and adopt, where some of the most exciting or unexpected business applications of generative AI.
Okay, so what are some of the most exciting or unexpected applications of Gen AI that you have personally encountered recently?
Beyond the now common applications like content generation chatbots, some of the more unexpected or deeply technical applications are truly fascinating. For instance, the use of generative models for creating highly realistic synthetic data. This is incredibly valuable in training other machine learning models, for example, especially in domains where there is real world data, but it's scarce, or it can be sensitive, or there are cost considerations for this. So think about training fraud detection systems, or like testing autonomous vehicles, those kind of scenarios where synthetic data is very important. So without needing millions of real world edge cases, we can generate that kind of data. We're also seeing it make inroads in scientific discovery, like designing novel protein structures with AlphaFold, for example, or materials with specific desired properties. So that's a very interesting application, in my opinion. So this moves far beyond simple text or image generation. It's into the field of actually generating functional physical designs, and in a more operational sense, sophisticated code, generating refactoring tools that understand complex legacy systems, or AI can draft initial responses to regulatory inquiries, for example. So it's these are pushing the boundaries of what we thought was automatable a few years ago. It's the depth and specificity that are often unexpected. So yeah.
Okay, so in your view, what is the biggest differentiator between those organizations that are or have successfully adopted GenAI and those that are still struggling?
From what I've observed, the primary differentiator often when it comes down to strategic clarity and like realistic approaches. Successful businesses they tend to start with well-defined business platforms and identify specific approaches, high impact use cases where GenAI can offer a genuine solution rather than basically adopting the technology for its own sake in their applications, which we've seen a lot recently. So they're not just these successful businesses. They're not just chasing the hype per se, but they're also understanding the critical importance of their data foundation. Gen AI, especially techniques like RAG, we'll get into it a bit later, I hope. These techniques rely heavily on the accessibility and data. So organizations have already invested in good data governance infrastructure and have a significant head start. So, in my opinion, these successful businesses, these like early adopters, these businesses have embraced a very iterative methodology where they start with small, manageable pilot projects and learn quickly from those both successes and failures, and they scale what works and they don't try to boil the ocean, so to speak. And finally, it's about people and integration. It's not possible without them. So, having the right talent or a plan to acquire it, a strong executive sponsorship that understand both the potential and the limitations of this technology, and focusing on integrating these tools into existing workflows rather than just deploying those as standalone novelties. These are key.
Okay, if I were to dive down into an area where your team has experience and let's say documentation, what kind of fundamental business problems does poor documentation or slow documentation can create where Gen AI can help?
Oh, the problems are manifold. They cut right to the core of the operational effectiveness. Firstly, there's the productivity drain. Employees, especially engineers, support staff, compliance officers, and so forth, they can spend an inordinate amount of time simply searching for information that they need to do their jobs. And this is time not spent on value-added tasks. Secondly, it leads to an increased risk of errors and inconsistent decision making. If people can't find the correct up-to-date procedure or the specific clause in the contract, or the relevant technical specification, they might rely on outdated information, tribal knowledge, or simply just they can more dangerously rely on guesses. So this can, as you can imagine, have serious consequences from product defects to compliance breaches. And then there's slower onboarding for new team members who struggle to keep up to speed with clear, accessible knowledge bases. And at a higher level, it can stifle innovation as valuable organizational knowledge remains locked away. So an unleveraged database source for future projects is not ideal. So it's a significant hidden cost in many organizations, in my opinion.
Okay, so historically, what have been the main challenges with traditional methods of searching and retrieving information, let's say from vast amount of unstructured data?
Traditional methods, we're speaking before generative AI, they largely relied on keyword search. They had faced several fundamental challenges. So, one of the most significant was their inability to understand semantic meaning, user intent per se. So, a user might search for cost saving measures, but the retrieved relevant document might use phrases like efficiency improvements. So it's not a one-to-one mapping. So keyword search would likely miss these nuances. Then there is the issue of information silos. Documents can often be scattered across various repositories. We've seen this firsthand. Different file formats are another problem, and then also obviously varying levels of metadata quality, if the metadata exists at all. So this makes a unified search experience incredibly difficult with traditional methods. Scalability is another major hurdle. As the volume of the unstructured data explodes, the traditional indexing and search methods can become like slow and unwieldy. So, in my opinion, these systems typically lack the ability to synthesize this information. And finally, they cannot answer questions directly, the semantic meaning being the base problem over there. They just return a list of documents, leaving it to the user to sift through them and find the actual answer, much like Google does. But they don't understand the context of relationships between pieces of information effectively.
So, how does Gen AI combined with other techniques fundamentally change or improve the process of finding relevant information, let's say from different documentation sources?
Generative AI, particularly when coupled with techniques like semantic search and retrieval augmented generation, RAG, as I mentioned earlier, offers a paradigm shift. The core improvement is moving beyond matching to genuine semantic understanding. Embedding models, they can capture the meaning and context of both the user's query and the documentation content, and this allows much more relevant results if the exact wording doesn't match. So you can ask questions in natural language per se. So secondly, generative AI can synthesize information and can provide direct answers rather than just a list of document links. So for example, a user could ask, what is our policy on remote work for engineering teams? And the system can extract relevant sections from multiple policy documents scattered across multiple silos, which we've already embedded, and then generate a concise, collated answer. So this enables more sophisticated interaction. Users can ask follow-up questions, ask for summaries, and this creates a more conversational and intuitive search experience.
Okay, so can you walk us through a specific example of a documentation retrieval project where you implemented Gen AI and the possible tangible impact that it had on documentation?
Certainly, we did work with a client of ours that had a lot of scattered documentation in multiple different silos, organizational information and onboarding documents, and all of these documents were in different formats. Most of those didn't have any metadata associated with them at all. And the key problem was that their senior engineers and maintenance people, they were spending on average several hours a week, sometimes like even a day, to trying to locate specific information. So for instance, like what is the specific solution for the problem X or Y, for example. So and then there was an issue with the versions of the documentation. So different versions contained different relevant information, and their clients had all different versions deployed. So in this case, we implemented a RAG-based system. We ingested and processed their entire corpus of technical documentation, creating a searchable vector index, embeddings, and then we placed that into a database. So after we did this, engineers could ask natural language questions. A tangible impact was definitely seen almost immediately. So it was quite significant. They reported an average reduction in this information retrieval time significantly. So one of the initial impact reports was that 60% of the time that they spent initially was reduced for documentation retrieval in this case. So this is particularly for the complex queries. So this directly translated into faster troubleshooting, reduced machine downtime, and definitely noticeable decrease in errors caused by um, incorrect, outdated specifications, and so on.
Okay, in your opinion, what types of documents and data sources are typically involved in these kind of Gen AI retrieval projects?
So it's usually a very diverse mix, which is part of the challenge. And the most common files are certainly PDFs. They can range from natively digital PDFs to documents requiring robust OCR. Then you have Microsoft Office formats, Excel files, presentations, and Excel spreadsheets, which might contain structured data to provide for unstructured documents. Then there are internal wikis, knowledge bases, often in HTML. We've seen that, and Confluence, SharePoint formats. There are also key sources. So what we've observed is that these are technical manuals, standard operating procedures, legal contracts, research papers, and all other different type of documentation that company uses are all prime candidates. So depending on the scope and privacy considerations, we might also see projects looking into incorporate less structured sources like email archives, transcripts from internal communication platforms, and basically just making sure that all of these are ingested and then answerable with semantic search. So these require careful handling, but we have basically essentially any repository we have made sure that any repository of textual business knowledge can be a candidate.
And what are the key data preparation and processing steps required to make large document repositories searchable and usable by those AI models?
Yeah, that's a great question. This is a critical multi-stage process. It often is the most time-consuming part of any RAG project. First, it's the ingestion and text extraction you need to get the raw text out of all of those different file formats. Um, the ones that I just mentioned, and this often involves using libraries like Atika for common formats and robust OCR engines if needed. So it could be like engine example of engines could be TestRact or some cloud-based OCR scanning options based on the specific requirements. Next is cleaning and pre-processing. This process is an important one. It involves removing irrelevant contents, like, for example, headers, footers, boilerplate text, for example, additional handling for special characters might be required, and potentially standardizing some terminology and fixing any OCR errors wherever possible. So once this is done, we actually move on to the main steps for the RAG pipelines. So the next step would be chunking in this case. So simply explained, chunking is large documents being broken down into smaller ones. So large documents are basically broken down into semantically coherent segments. So we call them these segments. We call them chunks. So this is critical because LLMs have context. So once we hit a limit of the context window, LLMs cannot continue to function. So you want the retrieved context to be focused. So only retrieving relevant information so that it doesn't exceed the context windows. And as you can imagine, the chunking strategy itself is very important. So we need to make a lot of decisions. For example, the chunking strategy itself, fixed if it needs to be fixed size, recursive, content aware, and those are like key design decisions. After chunking, the metadata extraction enrichment is often beneficial as well. And this allows to capture the document names, creation dates, authors, and even adding additional tags. So this can help improve the retrieval and filtering later. So finally, these chunks are converted into embeddings. So basically, this is usually done using a text transform model or a similar one, and then indexed into a vector database for similarity search. So vector databases are databases that can store specific type of data. So those are data sources that could be in the form of numbers, specifically that pertain to semantic meaning between different chunks of text, which we did in the previous step, and then we're now storing it to vector database for efficient similarity search. So this is the backbone of the retrieval system.
All right, but talking about the applications of generative AI, we definitely come across different large language models. And one application is the implementation of RAG, or Retrieval Augmented Generation. Could you explain me in simple terms what RAG is and why is it so crucial for making LLMs useful for internal business requirements?
Absolutely. Retrieval augmented generation, or RAG, is essentially a technique to make large language models smarter and more factual by giving them access to specific external knowledge or internal knowledge, depending on your use case. So, in simpler terms, when you ask a RAG system, it first retrieves the relevant information from a defined knowledge source, like your company's internal documents. Then it takes that retrieved information along with your original question and feeds it all into an LLM to generate an answer. The LLMs are instructed to base its answer on the provided context, and it's crucial for the internal or for the LLMs to be able to work this way, because just grounds their answer. This is also crucial for internal business data for a few key reasons. Firstly, base LLMs are trained on general public internet data. They don't have your company's specific or proprietary data or anything. And then anything that's happened since their training cutoff is not known to them. So RAG provides that missing context, and secondly, it significantly reduces the risks of hallucinations. So when an LLM confidently makes things up, that is not what you want. So by grounding these LLMs in factual retrieved documents, its answers become more reliable and tied to your actual data. So it's obviously traceable. You can often see which documents were used to generate an answer, and it is very vital for verification and trust in the business context.
And how does RAG help address the limitations of base LLMs, such as hallucinations, for example, or those cases where they don't have access to real time proprietary information?
RAG directly tackles these core limitations. Regarding your question around hallucination, the base LLMs sometimes generate a plausible sounding but incorrect information, and these are essentially predicting the next word based on their vast training data without a specific factual grounding for the query that you presented it with. So RAG mitigates this by providing explicit relevant context at inference time, and the prompt to the LLM easily becomes, for example, it can become based on the following information, answer this question. So and the question would be the user query. So the information is provided and the question is provided within the same prompt. So the model now has the relevant context. So this constrains the LLM to use this supplied facts, and dramatically it reduces the tendency to invent answers.
Specifically, in the context of documentation retrieval, how does a RAG system typically work end to end from a user's query to actually generating a relevant or desired answer?
Okay, let's walk through this typical end-to-end flow and drag documentation retrieval. So it starts with the user query. So the user submits a question or a search term in natural language. For example, what are the security protocols for remote server access? And the next step is that this raw query is transformed into a numerical vector representation. So it can be in multiple dimensions. So we call this an embedding, and using the same embedding model that was used to process the documents that we did initially, we process this query. The next step is to use this query embedding and search against the vector database containing the embeddings of all of the document chunks that we processed, ingested in our pipeline earlier. So the system then retrieves something that we call the top K, and it's the most semantically similar document in document chunks. So these are basically the pieces of information deemed most relevant to the user's query. So once we have the actual relevant document or the document chunk, the content of these retrieved chunks is then combined into an original user query to form a new prompt. So as I mentioned earlier, the prompt might look like this is the context, the chunk 1 followed by chunk 2, both of those similar top keys, and then we follow it with the user query. So what are the security protocols for this remote access? So we instruct the LLM to make sure that it only provides information based on those chunks, and the LLM generates takes in this augmented prompt, and the LLM processes this input and generates a coherent natural language answer using this information from the provided chunks and directly addressing the user questions. So finally, in this step, the user generated answer is presented to the user. So often good RAG systems will also provide citations or links to the original source documents from which the information was retrieved. So this helps with verification and trust. So that's the core loop. The query, the user asks the query, we converted it into embeddings, retrieved relevant chunks, augmented it into the LLM responses, and then generate responses. So, yeah.
All right, we have been talking about RAG models for a while now. It's time that we discuss some of the critical components that are needed to build a RAG system, like, for example, chunking or embedding models, vector databases, and retrieval algorithms.
To build a functional RAG system, several critical components need to work in concert. So, first, you need a data ingestion pre-processing pipeline. This includes the tools for extracting text from various document formats, cleaning the text, and crucially, a well thought out chunking strategy, as I mentioned earlier. So this helps breaking down documents into manageable states. So the next is the embedding model. We once we have the document broken down into several text models, we need to make those semantically coherent for the computer per se. So this is the embedding model is just a neural network. For example, we can use a model like SentenceBird or OpenAI's ADA or their other embedding models. These convert text chunks into the dense vector embeddings. So, which will be, as I mentioned earlier, that these are used in tandem with the user queries to match the semantic meaning. So the choice of embedding models is really important because it impacts the quality of your semantic search, and that is obviously a very important step. So the next step would be selection of a vector database, and this is, as I mentioned, that this is a specialized database like Pinecone, VV8, or others. FAS is one of my go-to databases. So these databases are usually very important for storing high-dimensional embeddings and perform very fast similarity searches. A retrieval algorithm is also key. While basic similarity search is common, more advanced systems might use hybrid search, like re-ranking the models to further refine the retrieve chunks before sending them to the LLM. So of course you need a large language model in this case. So GPT-4o is a good one. Gemini models are also very cheap. DeepSeek came out with a couple of great open source models as well. So did Llama. So this is the component that takes the retrieve context of the user's query to generate the final answer.
That was really interesting. And what are some of the common pitfalls or challenges that you have come across when designing and implementing a RAG system? Something that comes out of my mind is could be a chunking strategy or retrieval quality, or let's say if you were to maintain the freshness of the data.
There are definitely a few common pitfalls. One of the biggest is suboptimal chunking strategies. If your chunks are too small, they might lack sufficient context for the LLM to understand, and if they're too large, they can introduce noise or basically dilute the information. So in some cases, we've even seen that they exceed the LLM context window. So finding the sweet spot and then deciding on the overlap between those chunks is very crucial, and often an iterative process. So retrieval quality is another major challenge. If your retrieval step doesn't pull back on the truly relevant chunks, then the LLM, no matter how good it is, it will be working with poor input. This involves selecting the right embedding and tuning retrieval parameters. Maintaining data freshness is obviously an additional part of the puzzle. So it can introduce a significant operational challenge as well. So business documents change, new ones are added, old ones are archived. So the vector database needs to be kept in sync with these changes efficiently. So without constant like full re-indexing of the entire documentation. Evaluation is also notoriously difficult. So how do you quantitatively measure the goodness of a retrieve set, or like the faithfulness or helpness of a generated answer? It often requires a combination of automated metrics and human evaluations. And finally, managing context window limitations of LLMs. Even with RAG, there's often too much information, or if individual relevant chunks are very long, you can still hit the LLM's input token limit as well. So all this to say that this requires very careful design and how much context is passed. So yeah.
That was really interesting. But let's move beyond just answering questions. There's a lot of talk about Gen AI models when we talk about the applications of LLMs. Let's say if I were a layman, how would you define a Gen AI agent to me in a practical business application? And how is it different from simple chatbot applications, or let's say a single turn interaction of an LLM?
In a practical business context, I would define an AI agent as an AI system that can autonomously or semi-autonomously perceive its environment with like API or data, or basically defining goals, planning a sequence of actions, and then executing on those actions. So it can use tools to achieve those goals, And the key differentiators from a chatbot, to answer your question, is like from compared to a simple chatbot or a single turn LLM interaction. The first difference is multi-step reasoning and planning. So an agent doesn't basically just answer one question; it can break down a complex task into a series of intermediate steps. And the second would be tool use. So, as I mentioned, agents are designed to interact with other software. So, it can be like APIs, databases, or even other AI models. So, we can use these to basically gather information or perform any other actions. So, a chatbot typically doesn't book a flight or update a CRM or record on its own. So, thirdly, I would say the difference is autonomy and proactivity, in a sense. So, basically, while often operating with like human oversights, agents can initiate actions. So, we can ask them to initiate actions based on triggers or their ongoing assessment. So rather than just responding to the direct user inputs. So and a fourth would be like state management. So agents they often need to maintain context and remember information across multiple steps of a task, which is more sophisticated than the largely stateless nature of many simple chatbots. So think less like an answer engine and more like an automated task executor with reasoning capabilities.
That was interesting. What do you think? What kind of high level business tasks or workflows could an AI agent potentially automate or significantly enhance?
The potential here is quite broad, spanning multiple business functions. For instance, in a customer support environment, an agent could handle complex issue resolution by first querying the knowledge bases using RAG or other sources, and then, if needed, accessing the customer history via CRM API, for instance, and attempting a series of like troubleshooting steps and only escalating to a human if with a full summary if it can't resolve the issue. So another scenario could be in IT or operations where an agent could perform proactive system monitoring, detect any anomalies, consult if there are any anomalies, it can consult run books, diagnostic guides, and attempt like automated remediation. For example, restarting services, reallocating resources, and stuff, while also logging these events and notifying the relevant people. So, even in software development, an agent could assist with tasks like analyzing bug reports, searching code bases for relevant functions, suggesting potential fixes. Drafting code like unit tests are a potentially very promising implementation of agents. Yeah, writing unit tests, and then basically we use this in all kind of like software development scenarios, including even build processes. So the key is that the workflow involves multiple steps, ranging from information gathering from diverse sources and then decision making based on that information.
Okay, could you relate me or describe me an example of Gen AI where RAG interacts with documentation systems to perform any task? Let's say if I were to summarize any research report, or let's say if I were to draft a response from different policy document.
Yes, definitely. Let's imagine an internal policy compliance agent. Its task could be give a draft of a new marketing campaign, verify its compliance against our company's branding guidelines, ethical advertising policies, and data privacy regulations. And So here's my how it might work. So leveraging RAG and documentation. First we go with the decomposition and planning stage. The agent first would break down a task. It obviously needs to understand the campaign brief and then identify relevant policy documents and then compare the brief against them. So the next step would be the information gathering. So we'll probably use RAG in this step, but uh, in this step for each aspect, like for example, uh, branding, ethics, privacy, and stuff. So the agent would formulate queries to a RAG system and that it has access to, and basically the RAG system has access to all of the internal policy documents, like the legal guidelines and stuff. So basically, even past compliance reviews can be fed into the RAG system, and the agent generates those queries for the RAG system. And for example, the query might be what are the logo usage rules, or summarize the consent requirements for marketing emails. So once this is done, we now have the queries that are generated from the our system RAG to the RAG pipeline, and then we now move to the contextual analysis step. The agent receives relevant information snippets from the RAG system, then uses an LLM to analyze the campaign brief in light of this retrieved policy information, um, while basically identifying the potential conflicts or areas that need clarification. So, if needed, if a policy is ambiguous or seems to conflict with a new initiative, the agent might be designed to flag this and use a tool to say, like, create a Jira ticket for the legal team, attaching the relevant brief or so. So, in case of any confusion. And finally, the tool would compile a compliance report highlighting the sections of the brief that are compliance sections are that pose a risk, with while making sure that the explanations and citations to the documents are provided. This would be done through the RAG aspect, as I mentioned earlier, and any actions it took, like creating a Jira ticket, would also be mentioned there. So this agent uses RAG not just for answering a single query, but as a core tool, as you can imagine, and it's in a multi-step analysis kind of way with an action workflow. So that is basically how this would all go about.
That was a great example. And I was just thinking that, let's say if I were to perform a sequence of different tasks, should I expect technical or design challenges in building such a reliable and controllable AI agent that can perform those different sequence of actions?
Building a robust and reliable AI agents presents several significant challenges or opportunities, however you want to frame it. But the first is a sophisticated planning and reasoning stage. So basically, creating a plan that can adapt to dynamic environments or unexpected tool outputs. That step is obviously complex. So the agent needs to be able to decompose the high level goals into concrete executable steps and potentially replan things if they go wrong. So that is a very important thing that the agent needs to be able to do. In my opinion, the second one would be reliable tool use and error handling. So agents interact with external systems and APIs all the time, and these APIs can fail, return unexpected data, or have rate limits, and the agent needs to gracefully handle these errors. Maybe even try to find alternative tools. So, thirdly, I would say it's state management and long-term memory. These are very critical for multi-step tasks. The agent must maintain a context, remember previous actions and observations, and potentially learn from past interactions. So this would help it improve future performance as well. So LLMs traditionally have a limited context window. So this through this implementation, we should be able to basically so, provide guardrails that help resolve that. Fourth, I would say controllability, safety, and alignment are definitely paramount.
And how do you see agents fitting into the existing business process landscape? In other words, are they replacing employees or augmenting them?
Well, my perspective is that for the foreseeable future, the AI agents will primarily serve as to augment the human capabilities rather than the wholesale wholesale replacing employees in most knowledge work roles. So they are exceptionally well suited to handle the repetitive data intensive or time consuming parts of very complex workflows. But this, as you can imagine, frees up human employees to focus on tasks that require deeper strategic thinking, creativity, complex problem solving, and nuanced interpersonal relations. So it in these areas where human intelligence is definitely requires still far surpasses the AI. So you can think of an agent as a highly capable assistant. In my opinion, it can gather information, it can draft documents, it can monitor systems, execute predefined procedures. But the human remains in control for all of these critical decisions and strategic direction and so forth. So there will likely be some task automation that may lead to shifts in job roles, certainly, but it's, in my opinion, it's more probable that existing roles will evolve, incorporating AI agents as tools that enhance productivity and enable employees to take higher value responsibilities. We'll also see new roles emerge. That goes without saying that these roles would be, I believe, around designing, managing, and ensuring the ethical use of these agents. So, augmentation and evolution are the keywords here.
All right. I've recently seen many organizations have been building demos and prototypes for different LLMs. But I think building those demos is one thing, but productionizing it is a completely different story. So I just want to know, what does productionizing an LLM specifically entail?
Yeah, good question. So, productionizing an LLM application, much like any software, means taking it from proof of concept to a robust, reliable, scalable, and maintainable system that delivers content-based value. So, specifically for LLMs, this entails several key aspects, in my opinion. The application must handle edge cases gracefully. It must have comprehensive error handling and maintain a consistent performance under real-world circumstances. So this includes management of API failures and from LLMs, external providers, or any other tool failures. One of the key challenges in making sure that all of this works well and making sure that it is scalable is very profound when you work on these things. So scalability is an important aspect, in my opinion, in productionizing LLM applications. So the LLM application needs to handle needs to efficiently handle different types of workloads, from like a few users asking simple questions to potentially thousands asking complex questions, and then scale the underlying infrastructure like vector databases, as I mentioned, for RAG, and then model inference endpoints accordingly. So while all of this is in place, we also need to make sure that the monitoring and observability part is not ignored, because you need a comprehensive logging and performance metric backbone to your application. So quality metrics, for example, relevance in RAG or hallucination rates, cost tracking, and alerting to quickly identify and diagnose issues. All of these are very important. Finally, I'd say probably one of the most important in any application is security and compliance. So, implementing the strong data security measures, access controls, ensuring data privacy, adhering to relevant guidelines, especially when handling sensitive business data. So that is extremely important.
All right. So, talking about that, what are the biggest non-technical hurdles you encounter when trying to move an LLM that is still proof of concept into an actual production system?
The non-technical hurdles can often be more challenging than technical ones. So, a major role is change management and user adoption. Employees may resist to new tools or workflows, sometimes due to a lack of understanding. Another one we've seen is fear of job displacement or just comfort with existing practices. So, overcoming these requires clear communication, training, and demonstrating tangible benefits. Managing expectations is also very crucial. Proof of concepts often showcase the wow factor, but production systems face real world complexities, limitations, and costs. So, aligning stakeholder expectations with what's realistically achievable and sustainable is very key. Data governance and accessibility frequently emerge as roadblocks. So, getting access to the right data and ensuring its quality, navigating internal policies around the data usage, privacy can be a lengthy and complex process. This often involves like multiple departments.
All right. But talking about that, data privacy and security are paramount. I've seen that many organizations are always concerned about the security of their data. So, how do you handle sensitive business data, and specifically when you are building and deploying an LLM application that might be using those sensitive document sources?
We take a layered security approach. So that starts with minimizing data usage, only using what's essential and anonymizing wherever possible. So a role-based access ensures that only authorized users can view or interact with the sensitive data. In addition to this, our apps run in secure environments like VPCs, containerized sandboxes. Um, uh, these environments have encryption enforced both in transit and at rest. So, for model usage, we prioritize the enterprise grade or private deployments to keep data from being used in external training. Additionally, we filter inputs and outputs for sensitive content and follow all relevant compliance and audit protocols to stay aligned with regulatory standards.
All right. And since we are talking about the productionizing of an LLM application, and I'm just thinking along the lines of compute and scaling and latency and cost, what are the infrastructure considerations that should always be important when designing an LLM app?
It's a balance across compute, scalability, latency, and cost. So, hosting your own models may be GPU intensive. It may require heavy infrastructure, while inference endpoints and vector databases also need auto scaling in tandem with your on-prem environments. So, you need to handle scalability to account for the load variations. Latency becomes especially critical in user-facing applications. So, optimizing model size, batching strategies, and the geographic deployment location, it definitely matters a lot. And costs can spiral, so they can spiral quickly. So, you need an ongoing monitoring and optimization system to stay efficient without compromising any performance.
All right, cool. And you can guess my next question. Once an LLM application is live, how would I monitor its performance, its accuracy, and identify potential issues like, let's say, model drifting, or if I were to change user behavior?
Yeah, that's a great question. So we start with the basics, latency, error rates, and throughput, but quality is equally important to us. So we evaluate the responses, relevance, and accuracy, particularly in RAG systems. This often combines an automated evaluation with a human review. So we keep the humans in the loop wherever possible, and we also watch for shifts in user behavior. So any inputs that tend to catch drift or degradation early, those are very important. And then finally, we have some built-in mechanisms. So like thumbs up, thumbs down comments to add for the users to add valuable context and help fine-tune responses over time for their models.
All right, cool. I've recently seen that there has been a race of implementing Gen AI. Simply, it's just because it's so cool and it's so rampant everywhere. But how do you actually measure the business value of a deployed LLM application? I mean, what are the metrics that are beyond just technical performance?
Yeah, that's an interesting one. In my opinion, the key is linking it to tangible outcomes. The this That might mean faster task completion, lower optional operational costs, and fewer support tickets, or increased customer satisfaction. So, one way of doing this is that A/B testings or pilot rollouts can definitely help quantify these benefits. Ultimately, in my opinion, it's less about the model sophistication and it's more about whether the app delivers measurable impact where it matters most.
And building on that, what should be or what are the existing best practices for testing and evaluating LLM applications throughout the development lifecycle and after production as well?
My advice would be to start testing early and keep iterating. In development, use golden data sets and manual reviews to assess output quality. In staging, run full end-to-end tests and including adversarial edge cases. After deployment, we generally have some A/B testing involved, behavioral monitoring, and some regular reevaluation of the application just to make sure that it adapts to the evolving requirements on both the applications and obviously the users end as well. So this is implemented using observation of data patterns and so forth. So it's a continuous cycle, not a one-time certification.
And help me with this. If I don't want to disrupt the existing service, how should I manage the updates or changes to the underlying models? Or let's say if I were to change the data sources.
We rely on versioning and safe rollout patterns like blue-green deployments or canary deployments. For RAG pipelines, reindexing happens in parallel with the switchover only after validation. So, if the data is dynamic, we implement incremental updates to keep things fresh without disrupting service. Everything is tested in staging, and we closely monitor each rollout to ensure stability and catch issues early.
And what do you think? What are the key risks that businesses need to actively mitigate when putting an LLM application to production? Could be, let's say, hallucinations in critical outputs or misuse of application, and most importantly, security vulnerabilities.
Some of the biggest include hallucinations, data leaks, and bias. Prompt injections are a big one. Intellectual property concerns and runaway usage costs. So, over reliance on the model and the lack of explainability can also pose a lot of challenges. We've seen in a lot of examples over the course of our experiences. So, guardrails to mitigate these are definitely essential. Input output filtering, strict access controls, continuous monitoring, and ensuring regular audits is very important. While clear escalation paths need to be put in place, And all of these basically help ensure that the usage is safe and compliant.
All right. Uh, we've been talking about drags and agents and productionizing those applications and their challenges. But if I were to look beyond all that, how would you brief me on the single biggest obstacle that you think is preventing the wider adoption of sophisticated Gen AI in businesses today?
It's a leap from demo to production. Demos are designed to impress, but scaling them into reliable, secure, and cost effective systems requires serious engineering. So, infrastructure and alignment across teams is also a very important consideration when we're scaling to production. Many initiatives stall at this point because it's not about the idea it lacks potential, but because operationalizing it is the real challenge.
And what do you think? How important is the data quality as the foundational element for the success of any of these applications?
It's really everything. With generative AI, garbage in, garbage out really bites. So if your source docs are wrong or messy, your RAG system spits out poor context, and LLM will hallucinate or be misled. In essence, if you fine tune a model that uses similar bad data, so the fine tuned models usually inherit whatever errors or biases lurk in the training data. So agents driven by these bad data will also be making bad calls. So the bottom line is that the clean, accurate, and well-structured data isn't just helpful; it's the single biggest lift any serious GenAI project can have.
And what are the new horizons that we should expect, or the new capabilities that we might see when we talk about RAG and AI agents, let's say in the next 1 to 2 years?
Yeah, it's a really hard thing to predict, especially with the ongoing advancements going on in the industry. Case in point, the recent Microsoft build and the Google I/O. So, in my opinion, RAG will definitely get smarter about retrieval, hybrid search, adaptive chunking, and even recursive query refinement before the generation. You'll also see tighter fusion of structured and unstructured sources. Agents are a big one. 2025 is dubbed as the year of agents. So agents will, in my opinion, gain a stronger planning and memory and will handle multi-step workflows more autonomously with less human in the loop and learn new tools on the fly. So that would be an interesting one. And then agents might also collaborate with other agents on bigger tasks as well. So overall, the bottom line would be that the line between advanced RAG and lightweight agents will blur.
And for businesses that are just starting to explore the applications of Gen AI, where do you think they need to focus their initial efforts on?
So pick a narrow, high impact problem. So don't chase the tech. Look at where the people waste time. And there's one example that we definitely discussed in detail in this podcast was documentation and how that can be automated. So saving time using like slow documentation searches, repetitive content drafts, long reports to summarize. Start with the human augmented pilots and like the RAG powered knowledge sessions or draft generation. So you build trust and learn fast. So this is an important part. Make sure that you iterate really fast early on. Assess your data, what you have, how to clean it, and basically assess how clean it is and how you'll access it. Then run some small POCs, measure value, and as I mentioned, just keep iterating on the product and keep improving. And that's basically how the business approach would go.
And based on your experience, what's the one piece of advice that you would give to a non-technical team that have been tasked with building their production-ready first LLM application?
Yeah, great question. So, iterate fast and instrument everything from day one. Ship minimum version quickly and then measure performance. Cost measuring is also very important, so you don't want that to spiral. And keep testing quality with real users. So that would at the end of the day, it would really help you out. And you ensure that the logging, monitoring, and feedback hooks are set up front. Automated testing is very important, and you need to have some human reviews as well in that process. So that constant build up measure learn loop, so that is basically your biggest defense against surprises and in an unpredictable space.
And do you think are there any ethical considerations specific to these applications that we just talked about, let's say with documentation retrieval or different AI agents, that businesses must need to be particularly mindful of?
So for RAG, watch out for any outdated or biased source material and make sure that you respect the document permissions so you don't expose confidential info. For agents, my advice would be to clarify accountability, who owns the agent's actions, and build strong guardrails so they don't go rogue or deceive the users. Across both, maintain transparency so people know who they're talking to. If it's a human or an AI, and continuously auditing for bias and just is very important, and think through the workforce impacts.
Yeah, I totally agree with you there. And this has been an amazing session with you, and I particularly am taking a lot of insights with me. Uh, if I were to wrap up, what's the one key takeaway you hope businesses listening to this podcast must remember before applying generative AI effectively?
The key takeaway, the bottom line would be just to lead with the problem and not the hype. Gen AI shines when it's laser focused on a clear, tangible business need. Keep your eye on measurable outcomes, time saved, cost cut, happier users, and let that guide your technology choices.
All right, this has been a wonderful session for me, and I hope whoever listens to this has a lot to take with them. Really appreciate you for joining me here.
Yeah, this was a great conversation. Thanks again for having me. And if you're exploring GenAI and want to connect, please, the best place to find me is on LinkedIn, or check out the work we're doing on Xgrid's blog posts. You'll find some really great stuff there. Whether you're just getting started or scaling up, there's a lot of stuff that we can all learn from each other. Thanks for listening.